concept of inverses is very essential throughout mathematics, and so I want to show you a little insight into what inverses mean, especially in the world of functions. But to give you a little background, we'll go back to our arithmetic and talk about things that are opposites. In the world of equation solving, if you're solving the equation x plus 3 equals 8, we know what to do to both sides. And we do that because subtraction is the opposite of addition. So we need to do the opposite. To solve this equation, we need to do the opposite of multiplication. To solve this equation, we need to do the opposite of square roots. To solve this equation, we need to do the opposite of raising to the third power. And so opposites have special place in mathematics. Let me show you some other terminology. The number you add to 5 to get 5 is called something special, and of course that's a 0. Same thing with -7, same thing with 64, same thing with x. The 0 is referred to as the identity in the world of addition. So for the addition operation, 0 is the identity. Now, let's see where that comes in when we talk about opposites or inverses. The number we add to 5 to get 0 is -5. The number we add to -7 to get 0 is +7. These numbers are opposites in the world of addition. We also refer to them by another name. But these are called inverses or opposites. It's what we add to get the identity. The additive inverse of 3, the number you add to 3 to get 0. The number you add to -6 to get 0. The number you add to 1/3 to get 0. These have another name, and it's called opposites. The opposite of 1/3 is -1/3. In multiplication, a similar idea happens. The number you multiply by 5 and end up with 5 is the identity. And so the identity in the world of multiplication is a 1. And so, if we combine 5 with some number to get 1, in multiplication, that would have to be a 1/5. -7, these are the numbers that would multiply to give a 1. Those are called the inverses in the world of multiplication. The inverse of 3, the number you multiply by 3 to get a 1. The number you multiply by -6 to get a 1. The number you multiply by 1/2 to get a 1. And the name for those are reciprocals. Now, in functions, we have a very similar idea. There is such a thing as an identity. It's not so hard to figure out once you see it happening. If we take this function, what could we substitute for x and come out with the function we started with? Well, whatever that is, it's called the identity. And it's just an x. Here's another function. What do you put in place of the x and come out with the function you started with? Well, that would be an x2. And so the identity in the world of functions is x. Now, inverse, same thing. If we've got a function, what do we plug into the function and get the identity for our answer? It's not quite so easy. Now I'm going to show you some steps for finding that in just a second. Can you figure out what that would be? Well, perhaps you could. We have to multiply it by 2 and subtract 3 to come up with an x. However, let me show you the 3 steps. Step number 1, change the f of x to y. Step number 2, switch places with the x and the y. Step number 3, solve for the y. Add 3 to both sides. Divide by 2. And this is called the inverse. 2 times x plus 3 over 2. The 2's would cancel. The 3's would subtract out. And we get x, the identity. And so this is the symbol that means the inverse of that function, f with an exponent of -1. Now let me show you how we can determine if a function indeed has an inverse. If we draw a graph of a function, it has to pass what's called the horizontal line test. If you put a horizontal line on here, it has to touch in one spot wherever the line is. This one does, so it would have an inverse. This one does, so it would have an inverse. This one, however, does not have an inverse. This one that we studied recently, does have an inverse. And that's where we're going to be focusing in this chapter, the inverse of the exponential function. Now here, let me show you about graphing inverses. The idea is find the inverse function. Here's the 3 steps that we just went through. And look, if you draw a line that splits quadrants 1 and 3, the 2 graphs have to be symmetric about that line. The x's and the y's, step 2 of finding inverses, have switched places. Now let me show you the function 2 to the x, and we'll take some dots along that function and use those for finding the inverse. For example, look at the dot 0, 1. Well, the inverse is going to have a dot at 1, 0. How about the dot 1, 2? Well, the inverse will have a dot at 2, 1. And so I'll go through this a little quicker. The inverse means switch the x's and the y's. And so these dots become what you see in red. And then drawing the graph through those dots, this is what it would look like. Again, notice how it's symmetric about the line y equals x.